Hi 8th grade, this is Miss B. Today we're going to begin our lesson by going over the do now. The do now is similar to what we had for our exit ticket yesterday, in which we need to describe how to translate triangle ABC to triangle A prime, B prime, C prime. So a translation is when we slide an image in the coordinate plane. So we need to describe how to get from the triangle in the second quadrant to the triangle in this fourth quadrant. Right? I know that triangle ABC is my pre-image since I do not have any primes on the variables in my vertex. A prime, B prime, C prime tell me that this is my after image or the new image that we've translated to. So we're going to pick one vertex in this triangle. Let's start with A. And we need to determine how to move A horizontally across our plane and down to reach A prime. So we need to count our units. So when we are plotting points, our x variable comes first and the y variable comes second. So the first thing we need to describe is the horizontal shift. The horizontal shift going side to side is what changes our x value. Our vertical shift going up and down is what changes our y value. So in this case, we are going 10 units to the right. So in using our proper notation, we have a capital T to represent a translation, and we are going positive 10 units to the right. If we had been going to the left, this would be a negative 10. Since we are traveling 9 units down, we would use a negative 9, negative integer, to show that we must travel down. We can also use the coordinate rule in which we show what we are doing to each x value. In this case, we are adding 10. And what we are doing to each y value, which is subtracting 9, to note the type of translation we have. And lastly, we can write it in word form that we are going 10 units to the right and 9 units down from our pre-image to our image. So remember, instead of counting all the values on our coordinate plane going to the right and going down, another thing we can do is identify the points of our figure and use the coordinate rule on each x and each y value. For example, point B is at negative 2, 4 on our graph. So instead of counting how many units to the right and how many down, we can simply add 10 to that x value, and that'll give us a positive 8. And we can take our y value of 4 and subtract 9, which will give us a negative 5. So you don't always have to count how to get from one point to another. You can identify the coordinate rule by finding the distance between the x values and the y values. In today's lesson 3.3, we are going to be performing reflections and translating them both into word form and coordinate rules. So a reflection is a flip over our x-axis or over our y-axis. So our x and y-axis are going to be known as our line of reflection. It's going to be the line that we are flipping our image over. So a horizontal reflection is when we flip an image over our y-axis. A vertical reflection would flip up and down, and we would perform this on our x-axis. So let's take a look at some examples. In triangle ABC, we are performing a vertical shift across the x-axis to get to triangle A prime, B prime, C prime. Notice that each point is an equal distance from our line of reflection, which is our x-axis. Don't have enough space to write that out. Our line of reflection. So while A is 1 unit away from our x-axis, A prime on the opposite side must also be 1 unit away. Point B is 4 units away from our x-axis, which means B prime on the opposite side would also be 4 units. Same with C being 2 units away and C prime. Let's notice what is happening to each x and y value when we reflect over the x-axis. So if we take a look at point A, which is at negative 2, 1, A prime, or the new point, is now at negative 2, negative 1. Notice that the x value has remained the same, while the y value has changed in its sign. It's become negative. Since we are bringing our points from where the y values are positive to the opposite side of our y-axis where the values are negative, we can use the coordinate rule x, negative y, which means whatever your coordinate is, if you are reflecting over the x-axis, you would be taking the opposite of that y value. So if we take a look at point B, which is at positive 2, positive 4, when we bring it over to the other side of the x-axis, the y value changes its sign. It is now at negative 4. So we have B prime at 2, negative 4. And similarly with point C, which is at positive 4, positive 2, if we were to flip point C across our x-axis, we are negating or taking the opposite of the y value, which would be negative 2. So C prime is at 4, negative 2. It's a completely similar concept when we are reflecting over the y-axis. So let's take a look at triangle ABC, which is in our first quadrant, and when we reflect it across the y-axis, A prime, B prime, C prime is now in our second quadrant. So in graphing, each corresponding point must be an equal distance away from our line of reflection. So since A is 2 units away from our line of reflection, A prime will also be 2 units away. B is 4 units away from our line of reflection, which means B prime would be the same distance on the opposite side. And finally, point C is 5 units away from our line of reflection, which means that C prime must also be that same distance. Let's take a look at what our coordinate rule for reflecting over the y-axis would be. If A is at the point positive 2, 2, and A prime is at negative 2, 2, the y value has remained the same since we haven't gone up and down at all. But since we've flipped horizontally, the only variable that gets affected is our x. So we've gone from a positive 2 for x to a negative 2 on the opposite side of our y-axis. Similarly for point B. Point B is at positive 4, 4, and after reflecting over our line of reflection, it is now at negative 4, 4. So if we take a look at point C, which is at positive 5, positive 1, I know that I will have to negate my x value, which will be at negative 5, positive 1. So the coordinate rule for reflecting over the y-axis would be to negate x, or take the opposite sign for the x value, and keep the same y value. Let's take a look at the first two examples on page 1 of your class handout for today. So in the table at the top, we have different notations. We have the explanation in word form, the proper notation. So yesterday for translations, we used a capital T. So when you see this lowercase r, it'll tell you which axis you are reflecting over. And then we have our coordinate rule, how each x and each y might get affected depending on which type of reflection you're performing, either over the x or over the y axis. So in example A, we are reflecting point A, which is at 2, 5, and I've already plotted it for you, over the x-axis. So since A is at positive 2, positive 5, when we are counting in our coordinate plane, A is 5 units away from our line of reflection, which means that A prime will also be 5 units away from that same line, our x-axis, on the opposite side. So we have 1, 2, 3, 4, 5 units away on the opposite side. So A prime is now at 2, negative 5. Be sure to label your prime and to write the new location of that point. For part B, we are reflecting point B, which is at negative 2, negative 3, over the y-axis, which is this vertical line. So since B is 2 units away from our line of reflection, B prime will also be 2 units away on the opposite side. So B prime is now at positive 2, negative 3. So once again, be sure to write out your prime and to label each point with this respective coordinate. Remember for our coordinate rule, in example A, when we reflected over the x-axis, the x values remain the same, but since we flipped over to the opposite side of our y-axis, we have negated its value. So we went from positive 5 to negative 5. And similarly, when reflecting over the y-axis, our y value would remain the same, and our x value, since it is on the positive side of our x-axis, is now at positive 2, negative 3. Turn to page 2 so that we can reflect an actual image together. So in example number 2, part A, we are reflecting rectangle ABCD across the x-axis. So every point in ABCD will be an equal distance away from our line of reflection. Since B is 6 units away from our line of reflection, B prime will be 6 units away on the opposite side. Be sure to label your new point with its prime as soon as you've plotted it, to be sure that you've already taken care of that point and that you're not repeating the same one. A is 8 units away from the x-axis, so A prime will be 8 units away on the opposite side. So remember, just like we talked about yesterday, you don't have to take each and every single point and count the distance. Since we know we are creating a rectangle here, we can count the side length from B to C. So I know from B to C we are 6 units apart. So I know that C prime also has to be 6 units apart from B prime. So this is going to be C prime. And D is 2 units away from C, which means D prime will be 2 units away on the opposite side. You are still able to count an equal distance from your line of symmetry or your line of reflection, but it would save some time if you count the distance in the line segments to try to complete your image. Take a moment now to do part B and reflect this image over the y-axis, and you can unpause the video for the solution. Here's what your new image should look like. So remember, A and A prime should be an equal distance from our line of reflection, which is the y-axis, B to B prime, and each corresponding point. Your image will obviously be a lot neater than mine since you are not working on an iPad, and be sure to use a straight edge or a ruler to connect your lines. You'll spend 45 minutes today practicing reflections And the last 20 minutes of the period before your exit ticket, you will be doing a spiral review handout in which you will practice scientific notation and linear functions. Have a wonderful holiday weekend. Happy Thanksgiving.